Welcome to this explainer. Let's just dive right in, shall we? Today, we're taking a highly complex procedure, the Bombardier Q400 engine spool-up, and we're translating it into an absolutely unforgettable cognitive sequence. Look, if you've ever stared at that flight deck and wondered exactly how the digital and physical systems shake hands to wake up those massive turboprops, well, you're in the exact right place. We're going to strictly follow the exact sequence today, and we'll be using some pretty handy memory aids to lock this knowledge into your brain permanently.
Here's our flight plan for this explainer. We'll be covering the ground start sequence, how the FADEC system takes command, the run-up and limiting logic, auto-abort safety triggers, the differences during an in-flight start, and finally, the engine start panel callouts.
All right, starting with Section 1, the ground start sequence, or basically waking up the Q400.
So a ground start actually relies entirely on three systems working perfectly together. Your memory aid for this is SIF, starter, ignition, fuel. That right there is the trifecta you need to wake up the Q400. Now, before a single drop of fuel is even introduced, the starter/generator turns the accessory gearbox, which in turn spins the high-pressure, or NH, compressor blades to build up airflow. I want you to remember it like this: gear to air. The starter turns the gearbox, and the gearbox pushes the air via that NH compressor. Okay, next up, you arm the start system by selecting the desired engine right on the panel and turning the switch on. The trick here? Select to protect. You literally have to actively select an engine to arm its specific system. Finally, the sequence officially kicks off. You press the illuminated start switch light, and boom! At the very first indication of NH speed, you advance the condition lever to the start and feather position. Your memory aid for this step: push and push. Push the switch light, then push the lever to start and feather at the very first sign of NH.
Moving right along to Section 2, the FADEC system takes command, the digital brain.
Once you've manually initiated the start, the FADEC completely takes over. Your memory trick here? FADEC takes the wheel. You, the pilot, start it, and the computer finishes the job. When the digital gauge ticks to exactly 8% NH, the FADEC commands the ignition on and schedules the fuel flow based on three distinct things: NH speed, ambient temperature, and ambient pressure. Remember, 8 is the gate. At exactly 8%, the gate opens for spark and fuel. Interestingly, the FADEC intentionally uses just one igniter at this stage. Why? To identify any hidden failures in the dual-channel ignition system. Think of it as 1 to test, not 2 to rest. Using just one proves that the single channel actually works. But if fuel flows for 8 seconds without the engine actually lighting off, the FADEC steps right in. It instantly turns on both igniters and starts logging a fault code against that broken ignition channel. So remember, wait 8, then validate. It waits 8 seconds max before calling for backup and writing up a fault. Finally, as the NH gauge sweeps past that 50% mark, the igniters are automatically shut off. The memory aid here is super simple: 50 and finished. Once you hit 50% NH, the igniter's job is completely done.
Now, we just mentioned the engine lighting off, but what exactly does a light-off actually mean to the system? Well, a successful light-off is officially recognized by the FADEC only when the interstage turbine temperature, or ITT, increases by exactly 20 degrees Celsius. Lock this phrase into your mind: 20 degrees of light. A clean 20-degree jump means you've got fire.
Which brings us to Section 3, FADEC run-up and limiting, stabilizing the engine.
So the FADEC continues to independently manage the run-up until the engine reaches the requested NH speed or power setting. Your memory aid for this one is run-up by robot. The FADEC handles the throttle until things are perfectly stable. But there's a very specific safety guard programmed in here for ground operations. While you're on the ground, the FADEC actively limits the ITT. If the temperature even starts to approach the red line, the FADEC will literally reduce the fuel flow below the normal start schedule just to ensure the engine doesn't overtemperature. So remember, ground guard. On the ground, the FADEC guards the temp by cutting the fuel.
All right, Section 4, auto-abort safety triggers, hard failure limits.
This is absolutely crucial, understanding these three specific triggers. If any of these thresholds are hit, the FADC will automatically abort the start and shut the engine down, no questions asked. First, if there's no light off within 16 seconds of fuel flow being selected on. Second, if the ITT limit of 920 degrees Celsius is exceeded. And third, if the NH fails to reach 50% within 70 seconds, which basically indicates a hung or slow start. Your memory aid for this entire table is simply 16, 920, 70. 16 to light, 920 max heat, and 70 to 50.
I really want to pause on this number for a second. 920 degrees Celsius. This is your hard, non-negotiable ITT ceiling during the start sequence. Etch this number into your mind because exceeding it triggers an immediate, automatic shutdown by the FADEC. No exceptions.
Okay, so assuming everything goes perfectly, how do you actually know the start sequence has officially concluded? Well, when the start circuit is terminated, the select toggle switch physically snaps from the armed position right back to its center position. And that amber start caption, it goes dark. Your memory aid is snap to center. The physical switch snaps back when the start is a wrap.
On to Section 5 now. In-flight start differences, airborne adjustments.
Now, the process up in the air is largely the same, but an in-flight start adopts more of an all-or-nothing approach, with 3 critical differences. First, unlike a ground start, the FADC immediately commands both igniters on right away. Second, those auto-abort features we just memorized, they are entirely disabled. And third, the FADC does not actively limit the ITT by reducing fuel flow. The memory aid here is, in-flight is all in. Both igniters are on, there are no automatic aborts, and absolutely no temperature limits holding you back.
Finally, Section 6. Engine start panel callouts, physical controls. Let's look at the ignition control switch. It has 2 positions. Off means the FADEC disables ignition entirely, regardless of whether you're on the ground or up in flight. You'd use this if you need to do dry engine motoring. The norm position, on the other hand, allows the FADEC to activate the ignition during normal engine starts. Plus, in norm, the FADEC will automatically command both igniters on during flameout and surge accommodation. Your memory aid, norm for normal, off for air, meaning just air, as in dry motoring.
Next up is the engine start select switch. It's a 3-position toggle that's spring-loaded to the center, but it's magnetically latched into either the 1 or 2 position. Selecting 1 arms the start control circuits for the number 1 engine, and selecting 2 arms the number 2 engine. In both cases, you'll see an amber select illuminate right in the engine start switch light. Remember, 1 for left, 2 for right. Select your side to arm the ride.
And lastly, we have the momentary action engine start switch light itself, which is actually broken into 2 distinct segments. The amber select segment simply indicates that the start control circuitry of the selected engine has been successfully armed. Once you push it, the amber start segment lights up, which confirms that the engine start has officially been initiated. Your simple memory aid here, C-select, push for start.
And just like that, it brings us to the end of this cognitive journey from manual switches all the way to automated FADEC logic. We've covered the mechanical SIF components, those critical 8% and 50% milestones, and the crucial differences when you're airborne. But before we wrap up, I want to leave you with one final question to really test your mastery of the Q400. Can you confidently recall those exact 16, 9, 20, 70 safety thresholds before your next check ride? Take a second, review those numbers in your head, and lock them in for good. Thank you so much for joining me for this explainer, and happy learning.